Thanks everybody for coming. It's 3:45, last session of the conference. It's beer o'clock at this point. I know the beer just got rolled out, so I hope you enjoy what I have to show here. I think the slides are not showing. If you kick it over, yeah, there we go. Thank you. So yeah, if you want to catch up with me, you can find me on Slack, on GitHub, on Twitter. Good ways to get in touch if you need to. I have been working on Windows support at Puppet for a little over 3 years. That's involved a lot of core agent type and provider work, ecosystem integration such as with PowerShell and DSC, Azure extensions and images, and just dealing with like customer issues that come up. Most recently, a lot of UTF-8 work specific to international versions of Windows, et cetera. So just a quick agenda. We're going to talk about what app orchestration looked like in V1, super high level. I'm not going to get into crazy detail. Hit on quickly on what those enhancements were in the 2016.4 release that just dropped, how that integrates with Code Manager, take you through conceptually what my application demo is going to look like, what we're building out, and then actually get into the demo. This much talking over 4 days. I'm not used to it as an engineer. So if I can get a quick show of hands, how many people are using Orchestrator right now? Anybody? Ooh. And are we seeing mostly Windows folks here? OK, about 3/4 or so. OK, cool. So I will do like maybe a little bit more detail. We'll see. So in V1 of orchestration that we announced last year, there are kind of like two major things that we were talking about. Language additions for defining applications, and an idea of abstract kind of components that fall into these applications, and the idea of defining capabilities and producing and consuming these capabilities between components. They're kind of like an OOP interface, kind of, sort of, more like DTOs. The idea is that you can pass data between different things easily within an application definition. We also built in like environment level catalog definitions, so you can do cross-node orchestration kind of stuff. The other thing that we did was you introduced a whole bunch of tooling. So that included PXP agent, which is an underlying transportation mechanism for sending commands from the master to the agents through a broker sort of policy. And that was kind of like our V1. That was, we wanted to talk about application definitions, cross-node dependency kind of stuff, pushing those graphs out to production. So what's new in 2016.4? I think we've seen a bunch of talks about this. Ryan Coleman, I think, and Nick Lewis talked about this. I don't know if you guys had the opportunity to catch those talks. So a little bit about it in the keynote, but now it's about direct control. So you don't necessarily need to define an application. We're going to in this particular demo. But you can use the orchestration services to initiate commands out to all the agents that are in your infrastructure without them having to be specifically defined within an environment, which was one way that we used to be able to roll things out, or an application. So direct Puppet is basically that on-demand enforcement that I was just referencing. We introduced static compiler. There's a bunch of tricky stuff. I won't go into too much detail on that, about how that actually works. One of the big things that we have now are the client tools that were originally only Linux only are now cross-platform as well. So we have OS X and Windows support for those. That released today. I don't think we really gave a lot of press to that. We ship those as an MSI, and they're shipped out of band from the PE Davis release. So the demo is going to kind of revolve around driving change from Puppet from a Windows machine in particular. So no need to hop onto your master, make tweaks there, change code there, any of that kind of stuff. And the other thing is arbitrary node support. So we saw that demo in the keynote. That's the ability to filter the selection of nodes either through a list or a PQL query, which can reach out to Fax or PuppetDB, et cetera. So just a quick talk about what Code Manager does and how that workflow normally works. We start with a Git source code control repository that references all of the source code that you're going to deploy to your infrastructure. The branches are representative of your environments. So are people using Code Manager right now, or R10K? OK, so we have a good chunk, so people are pretty familiar with this stuff. Are people publishing to or using the Puppet code deploy tool on Linux right now? Okay, just a few. Okay, cool. So that's typically how you would deliver things once you checked code into your source code control repository, and then you wanted to push that code to your actual Puppet master, you would typically use the Puppet code deploy. I don't like the naming that we've selected there, because deploy to me means I'm actually rolling out that code to all my nodes. That's actually not what it means here. What it means here is that we are taking the code from our central Git repository and we're publishing it to our master. When you turn on Code Manager in PE, it enables the file sync service by default. And so what that means is the code from Git gets synced to the file sync master, and then it gets synced to all of the different compile masters that you may have in a master-master sort of setup. So really think of this as a publishing step. You're putting that code in the master and getting it ready to deploy to your actual nodes, your actual infrastructure. And then the enforcement piece is you can either use the normal default run interval to ensure that those changes actually get replicated out to your nodes, or you can use the orchestration client to drive that change. So yeah, a little bit of advice with Code Manager. Once you're in the Code Manager sort of workflow and you're using that file sync service that has been enabled, like don't touch the code that's in your master. Either it's going to get blown away, or you might accidentally change permissions in a way that is going to be difficult to reconcile. You may run into some weird issues there. Stick to the workflow that we've kind of prescribed. There are also some kind of side notes about like if you were previously using R10K and you're thinking about Code Manager now, we have a section of documentation that explains like some of the things you might want to watch out for, because they're not 100% compatible if you're moving from the old world to the new world. Yeah, and so Code Manager basically does the kind of shuffling around of that stuff on disk. Yeah, Git is the source of truth in this case. So Puppet files are also used in Code Manager, a quick way to define the modules that you're going to pull down in your code. So we have a number of supported modules that you're going to be using in this demo. This is a pretty basic Ruby file that talks about the versions of those dependencies. We're using a community module, and we're also using, in this particular instance, I'm running a Chocolatey server that I built, just a simple Chocolatey server. I modified the original module, made some changes to my own copy, and now I'm referencing it here. So yeah, I think you guys are probably going to be a little bit tired of the ASP.NET MVC app. We do it all the time. It is a nice canonical sort of representative demo, I think. And also in this case, like the reality is I don't really have the resources to be running multiple SQL Server instances on my laptop too, so bear with me here. So yeah, a little bit about pushing the envelope here. I am running 8 VMs. It's going to be on Vagrant 181 specifically, and VirtualBox 5.0 specifically. There's lots of weird issues. I could probably do an entire talk about issues with Vagrant and things to be aware of. Yeah, it's a very fragile sort of environment, so getting it dialed in, it can be kind of tricky. All of the code for the demo, including all the packages and everything, is going to be in a variety of, I think, 4 different repositories. This is where the actual Vagrant Setup lives in this particular repo. And yeah, we're about to enter the danger zone. So what did I need to do to kind of get the master ready for the demo? First off, I needed to enable Code Manager. There are some, if you're using newer versions of PE, which include what we call the MEEP installer, which uses Puppet to install Puppet in an idempotent way where it can recover from previous failures that it might have run into. There are a couple of basically variables that you're going to set that say, I'm turning on Code Manager, and also here's the Git repository that I'm going to point to, and that will make sure that that'll get set up by default when it provisions. That's all kind of taken care of within my Vagrant setup. I have a couple of scripts in there that kick off that part. The other thing that you need to kind of go forward with this is you need to create an RBAC user. By default, there's an admin user and an API user. Neither of those you can generate tokens to use for applications. So you need a specific user. I scripted it up. Again, you can get at the code that's in the repo by whacking that particular URL. You can generate that particular a user for your application deployments. So what did I need to do to kind of get the binaries ready? Because this isn't, I'm kind of glazing over these details a little bit, but normally you're going to have some sort of CI/CD sort of process that's going to be producing artifacts, shipping them to whatever your artifact repository is. That could be something like Sonar, it could be something like ProGet, it could be something like some other different OS kind of pipeline. But this is basically what I did. I took like a stock ASP.NET MVC app. I used some NuGet packaging around it to produce a chocolatey package. I'm running the simple server. And in this case, what I'm going to do is simulate what a Jenkins server might do if it were to publish assets, but I'm going to do that at the command line. Hopefully, yeah, that's really tough to see. But one of the things I was just going to point out is that inside of my chocolatey package, I parameterized it in such a way so that you can specify the destination of where the package is going to get installed. So you can drive that from your manifest by passing it through to chocolatey as a parameter. So this becomes important if you want to lay down, I don't know, a particular web package in a different location under inetpub www root, something like that. But yeah, you can see where the parameterization is kind of done there. This is kind of some really, demo code, basically. We look for an install dir, and we use that. The other thing that I'm doing at the bottom is like you wouldn't do this in production. You would not just say, I'm going to blow over the entire directory that was there with this new copy, because chances are there may be some important data there that you might not want to blow over, especially if you have things in app data, et cetera. So we've got one other machine kind of in this set of infrastructure, and it's the Windows 10 node that I'm going to be driving everything from. This one I set up outside of Puppet's control. And when we provision the whole stack, this one actually has to come first because it's hosting the Git server that Code Manager is going to hook into. So on this particular server, I'm running basically kind of a GitHub clone to host the Git source. I have generated the token for that RBAC user that I was talking about that I'm going to use from the command line. I've configured the PE tools, which involves setting up the token, making sure that it's registered, has a particular lifetime. By default, when you ask for tokens from RBAC, you're going to get tokens that have 30 seconds. They're only going to be able to be used for 30 seconds. For this demo, I said just give me one that's valid for a year. We don't need to futz around with like really short lifetimes and regenerating tokens and all that kind of stuff. I have staged version 0.0.1 of my particular web app, pushed it up to the internal chocolatey server that I have running, and I have done a code deploy of this V1, kind of basic vanilla app using defined types, which we'll get into in the code in just a second. This is representative of that first run. I have 5 different nodes that have been modified. We have a load balancer. We have 4 web nodes, 2 in a green cluster, 2 in a blue cluster. It took about 2.5 minutes to deploy that V1 of the application, including setting up IIS. So this is all the nodes, all 5 nodes, 2.5 minutes on a pretty slow kind of setup, given that it's all running on my machine. So are most people here, are people doing blue-green style deployments at this point? I know that it's not necessarily modern infrastructure necessarily, and I don't know that that's really necessarily a bad thing, because I think Luke and Deepak, if you saw his talk, hit on some really good points about the fact that we need to have a really wide range of application models that we support when we deploy things to production. There's a lot of legacy code out there. There's a lot of applications that fit pretty well into this model. And I think it's a good starting point just for a demo. Not everything's containerized. Not everything's running Docker. So the basic construction of this application is we have a load balancer. Unfortunately, no F5 available, so I'm going to use HA proxy. We've got just one HA proxy node running with 256 megs, something like that. 2 Windows servers. Again, no SQL Server database, a little bit on the heavy side for this kind of demo. We're going to swing in V2 of the app. We're going to point the load balancer at it, and we're going to take the whole nodes out. So very kind of standard blue-green kind of deployment. There's a bunch of different ways to kind of iterate on this or do different mechanisms for this. But yeah, so let's kind of get into the demo. I wanted to include one picture of my dog. There he is with an infrared camera shot. One of my coworkers just got a phone with an infrared camera. I've never seen that before. Pretty weird. Yep, miniature dachshund, little 12-pound wiener dog named Otto. Okay, so it looks like it's not showing the, let's see. Oh, maybe my RDP session died. Nope. It's a little tricky with the AV setup up here. Strangely, my RDP session has disappeared. You can see that part. But actually connecting to RDP is not doing anything. There we go. That was weird. OK, so let's talk a little bit about how things are defined currently in this application. Are people using roles and profiles right now for setup? Is that a pretty common sort of pattern people are following? OK, so only a handful. So the basic idea there is you define particular profiles and then bring those up to a role level to help and classify nodes with a particular role. I'm not using a ton of role and profile in this because of the way that the application is architected. But the main idea here is that we are going to have a base profile on Windows. All the Windows machines, I've turned on Chocolatey, and I've pointed it at the internal Chocolatey server that I've got running within this Vagrant setup. So that is the #1 prioritized feed here. So that when we ask our custom application to deploy, it's going to go to that particular feed to pull it down. So pretty straightforward kind of stuff. The include Chocolatey, by the way, this will actually provision and install Chocolatey on the machine, get it all prepped and ready to go. So if you're using our supported module and you want to get Chocolatey in your box, it's as simple as this, basically. This is my site PP. And we can see that I've included the Chocolatey server role on the Windows 2012 Choco node. And let's take a quick look at Chocolatey server. Chocolatey server also pretty basic. We're just including the Chocolatey server define type. Back to site PP. We are also defining that version 0.0.1 of our application. Oh, whoops. I'm looking at this code going this isn't quite right. Quick revert to, that's step 2. It must have happened when RDP was hidden. OK, so here's the simple non-application. Just forget you saw that code just a moment ago. What we're doing basically here is we're saying that we're going to use the app profile on all of our Win 2012 web nodes. So I've used a really, really simple classification here that's derived based on a regex. So I know all of my nodes are named with this particular convention. This is probably not what you're going to do in production. You can either drive this through data or you're going to use node classifications. But for the sake of this demo, we have 4 nodes. They all match this particular pattern. We're going to say we're going to put the app profile with my Puppy Labs app of version 0.0.1. And the definition for this is a define type that basically accepts a couple of parameters, the app pool, the app root, the port that's going to run on. And we also have a little interesting thing that I had to add here, which is what happens when you need to drop an application over an existing application IIS? Well, there's a good chance you're going to have locked binaries, right? This is probably not, the way that this is currently set up is not how you'd want to do this, because you can't just stop the world across all your websites when you're ready to deploy a new version of your application unless you have a specific downtime window, or you have some understanding, or you've already taken those machines out of a load balancer. So we're going to kind of move in that direction. But right now, we've got this script that says, OK, end up killing the app pool. Actually, we're going to actually kill the whole entire website in this case, which is pretty heavy-handed, which is this code right here. And that's going to be based off of just determine whether or not this version of the app is installed. If it's not, that means we're probably going to have to stop the entire app pool. We're going to stop the website again in this case, and then install the package from the Chocolatey feed. The parameterization that I was referencing earlier is passed through the install options argument of the package type when you're using the Chocolatey provider. So you can see I'm passing in that installation directory. That installation directory is driven off of the app root that was passed into the top of this define type. And you'll see the simple kind of standard Puppet require here that says, OK, stop at the site if necessary. I've also modified the web config template in a way that we can parameterize it. just using a simple Ruby ARB template here. Oops. You can see we're injecting the value of custom errors into this so that we can define, if, for instance, we were running in a dev environment and we wanted to make sure that the yellow screen of death shows for debugging purposes, we can turn that on. We can vary that behavior in production. There's some other values that we're going to see that are set. Package version here, we're passing through. This is actually just going to show on the web page just so we know what version of our app was deployed to production. Obviously, typically for security reasons, we don't do that sort of thing. But for the sake of the demo, you'll see why I'm doing that in a second. So yeah, this is what the application definition is going to look like in terms of modifying, laying down config, and using DSC to configure the app pools in the website. Pretty standard kind of IIS configuration kind of stuff. I won't go heavily into the details here, but this is kind of the basic thing that you would do when you're going to roll out an ASP.NET MVC site. And of course, at the end, what do we have to do? We have to start the website back up if we stopped it. So that's all kind of covered within that particular definition. So again, this is how we're pulling it into those 4 nodes. We're saying all 4 of these web nodes deploy that application with that package. We've got our chocolatey up here. And now we need to put things into our load balancer. But like, how would we normally do that if we don't have static hosts? The IP part in particular, for this particular instance, you probably want a little more flexibility, a little more dynamic capability to be able to do this kind of stuff. And people have used exported resources in the past for this. It's a little bit complicated to set up. Is anyone using exported resources for this kind of thing? So are a few people. Are you guys running into some issues or struggling with it a little bit? Yeah, it's complicated, right? It's difficult because there's no really great way to share that information between components like we have in the app model. So that's one of the primary reasons that that stuff exists, that produces and consumes kind of concepts. So yeah, so this isn't great because now we have to know all the host names of everything and the IP addresses. And like, how are you going to know all this if you're not pulling it from? You can obviously keep some YAML file around that has this stuff defined somewhere. There are other ways of doing this that are a little bit trickier, but it gets complicated pretty fast. So let's have a quick look in our browser. I've got our PE console going first, which is running in this Vagrant stack. Here's our chocolatey server that's up and running. We can get a good idea of what our packages are here. Go Choco Go. So we've just got our version 0.0.1 app. Won't worry about that too much. This is the control repo running on this local box, but here's the GitHub style view that this GoGS server provides. Pretty standard fare stuff. Here's what HA proxy is configured like currently. Here's the stats page. So we can see that we've just registered that one node in there, but I didn't provide an IP address. So what's going to happen when we try to whack this thing? It's like, we're going to have a problem, right? So this is probably not a great way of setting things up. People have managed to get this sort of thing working, but again, it's pretty complicated. There are better ways of doing this. And yeah, I'll just show you really quick, too, that I have the 4 individual web nodes running. Go, browser, go. So here's Puppy Labs version 0.0.1. You can see that we've got the web green 1 node is running this with a particular IP. Each one of those tabs represents each one of those individual websites, so we can take a look at that later. So let's do something here to kind of level up this application a little bit. So this is going to be like our transition part 1. What are we going to do to the code to make it like a little bit better? So now we're going to try to define an application. We're going to say, OK, we want to try to be able to exchange some information between different components in our application, especially when they may have ordering. Not everything has ordering dependencies across nodes. But when you do have those sorts of problems, you need something like orchestration that can kind of describe those relationships so that things get ordered properly. So very simply here, we've used the new application keyword. We're calling this just simple application. We're passing in a version. We're saying what load balancer port are we going to be running on. We're going to create an instance of that defined type, profile app. We're going to create an instance of that defined type, profile load balancer. The reason that we have the profile prefix in here is because of the way that the site profile layout is specified. So that's basically like a module living inside of your code manager repo, just like the roles are same sort of convention. So you would follow the normal module naming kind of nomenclature there. Typically, when you start to refactor this code, you may pull this out into an individual module that would then have a different namespace in front of it. But the basic idea here is going to be that we are exporting an HTTP capability from both the app and the load balancer. We're also going to take in some HTTP capabilities as balancer members of the load balancer. So this is that mechanism for sharing the information. So let's take a quick look at what the load balancer looks like. So the important thing of the defined type for the load balancer is that we have specified this balancer members, for one. We have some default options for how we want to configure HA proxy. We're using round robin in this case. It works pretty well for demo sake. Be careful about using cookies. Cookies won't work right with round robin. We're using the default kind of HA proxy setup, and we're pulling in that base profile. We're not really doing anything on Linux nodes in the base profile, but that's kind of a convention to pull in base profile. So we have that HA proxy listener, and we're doing collect exported false because the HA proxy module has the ability to collect exported resources. We want to disable that functionality, and we want to make sure we're using application orchestration. We have our stats listener, and kind of the more interesting thing at the bottom is that we are iterating over the collection of balancer members that have been provided to create instances of HA proxy load balancer member. So this is a little bit different than you might normally sometimes see these connections provided between the web app and a SQL app or a database app. Normally, the web app will consume the database produced by the database app so that it's pulling in the right configuration, connection, port information, that kind of stuff for the database. We're doing it a little bit differently because we're doing it programmatically here. So the main point here, though, is that out of the capabilities that are defined, we're going to pull host IP and port out of those. So that little piece of data that's traveling between the load balancer and the web server is going to get collected to define instances of those balancer members. We're also going to produce HTTP out of this. So we're mostly doing this for kind of health check reasons. We kind of get that by default based on the fact that I'm pulling in another module that we have that's called app modeling. We recently introduced that one. That defines a couple of core capabilities that we want people to build on. One of those is HTTP. Another one is database. There's also a couple of interesting functions that are implemented in there. I'll go into the details of one of those in a couple of minutes. But this is kind of like a bare bones module that may help you to model other higher level applications. I think we intend to introduce more capabilities. I'm actually not on the app orchestration team. I mostly do Windows stuff. So I'm not sure exactly what the roadmap is there for kind of additional capabilities there, but those are some pretty common ones. OK, so let's close that down. We don't need to look at our web config anymore. We have our site, our init.pp, which defines our simple application. That's going to change in a moment. We have our site pp, and we have this. We want version 0.0.1 still. We're going to roll it just out. The profile app component called Puppy Labs is going to roll out to that web green 1 node, and we're going to make sure we pop it into the load balancer. So let's kind of run that and make sure everything looks good there. So the steps here are we've committed code, right? We're going to push it up to our GitHub repo. Oops. It's going to help to use the actual upstream repository. OK, so now we've pushed that up to our Git repo, right? We're ready to start moving those bits around. We're going to use the Puppet code tool to deploy the code. This is going to tell the Puppet master, OK, you are going to need to grab the latest version of that code from the Git repo. It's ready. It's time. We need to move it into an area where we can start to roll it out into production. Again, I think this command should probably be named publish, but the ship has kind of sailed on that one. An interesting thing to note, too, is that I specified all here. You might not necessarily use all. I believe that switch you can use to specify environments. And the wait part may be slightly misleading if you have a master of masters and many compile masters because of the way that the file sync service works under the hood. So wait means the master of masters, file sync master service has the latest copy of the code and it's ready to go. But it doesn't necessarily mean that it's been copied out to all of the nodes just yet. There's a period of time that may elapse. I think that the file sync service team told me by default those agents will check in on a 5-second interval to check for new code. But if you have many compile masters, maybe they become disconnected from the network, et cetera, et cetera. It's an eventually consistent sort of state. So now that we've defined an application, let's take a look at what the app definition looks like. So kind of on that slide before, you saw that everything kind of rolled out in sequential order. There were no previous application definitions. Here, we actually have a hierarchical kind of definition here that talks about, OK, I'm going to need to roll out Puppy Labs to that one particular node first. Then I'm going to need to update the load balancer. Let's run that application to actually deploy it. Now we've kicked off the orchestrator. We're telling it start to make those changes on demand now. Don't wait for the run interval to elapse, that default 30 minutes. Let's kick this job off right now and ready to deploy. Give that a moment. Typically, in my demos, this is taking about a minute. Again, I'm in a very kind of constrained environment here, so it's probably going to run a little bit faster in your production architecture. OK, so you can see that nothing changed on our web node. There was no need to change. We already had this application rolled out, right? So you kind of get that kind of canonical view of like what resources have been modified, skipped, et cetera. We're updating the load balancer. And there we go. We had one change. So if things worked the way they were supposed to work, this 400 bad request should produce a 400 bad request. Yeah, I actually saw this earlier with, I think this is an IE bug. Yeah, there we go. So we have deployed this thing out to our load balancer now. The definitions have been changed. You can see previously that we had 0 hits, and now we can see that we're starting to get hits against that particular node. We'll kill our bad request page here. Thanks, IE. OK. So kind of what's next with this? So we've only got this one node registered here. We probably want to do some more interesting stuff. What I'm going to do first, though, is I'm going to kind of, let's get the next deploy kicked off and running. Based on, oops, we're going to run our, yeah, thanks, Glenn, for this idea. We have our YOLO script, so we're basically encapsulating those 4 steps that we did previously by hand. So step 1, push to production. Step 2, run the code deploy tool. Step 3, take a look at what the job definition looks like. Step 4, actually deploy the application. And while that's running and things are updating, let's go back and take a look at the code to see what we changed this time around. So we've registered a few more nodes in our application definition, for one. For 2, we've used this collect component titles function. Now, the application modeling module that I was referencing earlier defines this particular function. So this is a way to kind of collect up the names of the nodes in a way that we can start to build up things programmatically rather than kind of statically defining them. So in this particular case, we have a slightly more complicated, instead of that simple app we were using before, we now have this slightly modified Puppy Labs app. The Puppy Labs app is much more advanced than what we saw in SiteBP because it does this dynamic building of capabilities and plugging those components together. And again, the same way that we were doing things before with balancer members, we're now passing in that list of HTTP capabilities directly in. So we just redeployed that whole app. I think that we also, no, OK, yeah, we just redeployed that. We've got 4 nodes running now. HA proxy updates, we got all 4 nodes in there. If we hop over to the load balancer, now we can start to refresh this, and we see that the name of the agents change, or the name of the particular nodes change. Do round robin style. OK, so now we've got kind of this arbitrary passing in of HTTP capabilities. Let's start to do something a little bit more interesting. Back to the editor. And let's take a look at the code again. So in this particular case, now we define a cluster inside of our define type. So we want to pass in the cluster name that we want to deploy this to. So now we're starting to separate things out into blue and green as a concept, right? Conceptually, we decided we want to be able to control deploying to different sets of nodes through an arbitrary kind of construct that we put into our code. Again, this is something you'd probably drive through YAML definitions or similar sort of data-driven capacities. But for the sake of the demo, we're going to do it like that. So we're now continuing to pass in all of the nodes that we were previously, but we now have this cluster name that we're passing in. We're using that as a parameter to then filter out the nodes so that only the blue types are being deployed. Yeah, it's basically, you would probably want to use like node classification or something similar to that to drive something like this. But I just wanted to kind of go through like what the concept might be if you were to pass in an arbitrary variable like that, right? The basic idea is you're segregating between a collection of nodes in some way. OK, so that's all rolled out now. Let's take a look at what our load balancer is reporting now. Now we're just toggling between blue 1 and blue 2. And if we update like what our stats page looks like and what the definition of HA proxy looks like, we've only got 1 and 2. So that's good. So now we kind of got the basis for being able to control the version of the application that goes to an independent cluster of nodes, right? So let's say now we want to deploy version 2. And we've got blue running, so let's instead change this to green. So I'm just going to do this commit kind of, oops. OK, so we've got that code committed. All we've done in this case is we've bumped the version of the package that we're going to install, and we've said we want to install it on the green cluster of nodes instead. And we can YOLO this again. So very simple change here. Like, as far as our kind of conceptual model around this stuff, we've changed 2 variables, right? And now we're changing where we're deploying this application to, an entirely different set of nodes, and we're making sure that it's done in the order that we want it to be done. So as this is happening, we're continuing to serve traffic from the old set of nodes, right, until that V2 of the application is deployed to the new set, Once it's deployed to the new set, then the changes are made to the load balancer to reflect that particular change. So we'll give this a moment. Oops. Sweet. So our V2 of our app is now live and ready to go. So we take a look at our stats page. Everything's updated to the green cluster. We're going to hop over to see, like, OK, these devs just said they had this awesome V2 of the Puppy Labs app. Let's check it out. Are we still on the right cluster here? Yep, we see our V2 is showing up. Oh, you know what we forgot to do? I'll just work this into the demo. So I actually forgot to do something. I forgot to actually push the V2 of the chocolatey package up. So let's take care of that. Let's see here. I think I actually have a script that I put together for this. Oops. OK, so I failed to do that first, right? So I accidentally pushed up an application version that didn't exist, or asked for a version to be installed that didn't exist. Oops, I'm in the wrong directory again. So knock on wood, everything's like made it so far, as far as like these VMs not blowing up. So that's a good omen, I guess. Oh, it's actually interesting that the change is not matching up. This part of the demo I did not test. There's an implied ordering there. So our load balancer actually won't need to be updated in this particular case. So let's see if our new app got deployed. Yay, it did. OK, so here's our green cluster. We're running version 2 of our app. Devs made some awesome changes, put some new great dog pictures on there. And now you're cruising around. You say, OK, this looks pretty good. Let's test this out. And it's like, everything's looking good. Uh-oh. We just deployed it like a broken package. So what would you typically do at this point? Well, we're going to want to oops. So I'm actually going to revert that commit I just did. I decided that this app is too broken to be running in production. We're going to turn around pretty quickly on this. And we're going to change the load balancer and point it right back to that old version. You're coming over because I'm out of time, right? Perfect. Right at the end. So while that's running through, I think you guys know what the punchline is here, where our load balancer is going to be running V1 of the app once again. just kind of a simple workflow for kind of managing application deployment like that. Obviously, you can build out more complicated workflows on top of that kind of basic model and using application orchestration. Does anyone have any questions? Or is everyone ready to go home?
So just around when you were deploying the application before, that didn't actually fail when you changed the version number?
Yeah.
I would have thought that would be the case. Can you actually force it to do that? Is that a chocolatey thing?
Yeah,
or?
that actually, to me, just looking at that in passing, seems to me like there was a problem propagating that error state from our chocolatey module back through. So Rob will have to take a look at that later and see. Because that version of the package did not yet exist upstream, we tried to grab it, and it didn't fail, but it should have. That's a good question.
The examples that I've seen kind of have static node definitions in your hash right there. Is there any way to feed in dynamic nodes? Like, let's say if I have a group of web servers, just dynamically feed that in?
Yeah, there's some more complicated setups that we have examples of that show that kind of stuff. One thing that you could do is you can actually use the same example in provision Docker containers, for one. There are some examples that we have in our RG bank. I don't know if you've seen that particular application that we have on our, I think it's actually a module at this point. I've seen people do application definitions inside of YAML and feed that in programmatically. So anywhere where you can pull data, you should be able to define nodes that feed into your application definition. I'm sorry? Lookups into that, I am not sure of. The way that I've seen we should probably take this one offline. We can talk about it a little bit afterwards, just so I can show you maybe what the other models look like. They are a bit more complicated when you start to use Puppet programmatically to pull in data and construct things dynamically. Yeah.
We're out of time, unfortunately, even if this is very interesting. Thank you very much, Ethan. Warm applause.